Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Intan Kartika. So, in this video, I'm gonna explain some topics about basic of mathematics. There are three topics. The first one is prove the validity of an argument. The second one is proof by contraposition, and the last one is proof by mathematical induction. So, without any further ado, let's get started. Okay, the first topic is prove the validity of an argument accompanied by quantified statement. How to prove the validity of an argument? Now, I have an example here, so let's prove this. The argument is show that premises a student in this class does not study and everyone in this class passed the mid-test. Imply the conclusion someone who passed the mid-test does not study. Okay, the first step is let Cx be x in this class. Let Sx be x study and let Px be x passed the mid-test. Okay, from this we have the premise. The premises are there exists x, Cx and negation Sx, and for all x, Cx then Px. And the conclusion is there exists x, Px and negation Sx. Okay. These steps can be used to establish the conclusion from the premises. The first step is write the given premises and the given conclusion, like number 1 and number 2. And then the third step is by existential instantiation from number 1, we get Ca and negation Sa. And the fourth step is by using universal instantiation from number 3, we get Ca then Pa. Okay, next. By simplification from number 3, we get Ca. You guys can also see the rules of inference table here to see that which one that we use to prove this argument. Okay, the next step, number 6, by modus ponens from number 4 and number 5, we get Pa. And the seventh step, by commutative property from number 3, we get negation Sa and Ca. Step 8, by simplification number 7, we get negation Sa. And then the ninth step, by conjunction from number 6 and number 8, we get Pa and negation Sa. And the last step, by using existential generalization from number 9, we get there exists Px and negation Sx. Okay guys, so we have proof, we get this conclusion. As we can see, this conclusion is same as the given conclusion. So this argument, the given argument, we have proven that the argument is valid. Yay! Okay, next, move to the next topic. The next topic is about proof technique. Proof by contraposition. Contraposition is a method of indirect proof. Contraposition utilizes the principles of mathematical logic, namely P then Q congruence with negation Q then negation P. That is to prove that the statement P will result in the statement Q being true. Then simply prove that the statement is not Q and the result is not P. Okay, let's go to the example. If n is an integer and 11n plus 7 is an even number, then n is an odd number. The first step to prove this is let P be 11n plus 7 is an even numbers, and let Q be n is an odd numbers. By contraposition, what we prove is that if n is not an odd number or n is even number, then 11n plus 7 is not an even number, or 11n plus 7 is odd number. Suppose there is an arbitrary even number n. From the definition of an even number, n can be expressed as n equals to 2k, where k is an integer. Furthermore, because n equals to 2k, then 11n plus 7 can be written as 11 times 2k plus 7 or 2 times 11k plus 7. Because both of them has the same value, right? Okay, and I choose to use 2 times 11k plus 7. Okay, we write 7 as 6 plus 1. And then we can write 6 as 2 times 3 plus 1. So we get 2 times 11k plus 2 times 3 plus 1. By using distribution property, we can write this as 2 times 11k plus 3 plus 1. Okay, 11k plus 3 can be exampled with m. So 2 times 11k plus 7 equals to 2m plus 1, where m is an integer. Based on the definition of an odd number, 2 times 11k plus 7 or 11n plus 7 is an odd number. It's proven that if n is not an odd number, then 11n plus 7 is also not an even number. Indirectly, it can be concluded that if n is an integer and 11n plus 7 is an even number, then n is an odd number. Yep, so we have proved this. The next topic still about proof technique. The next technique is proof by mathematical induction. Proof by induction is a very powerful method in which we use recursion to demonstrate an infinite number of facts in a finite amount of space. The most basic form of mathematical induction is where we first create a propositional form whose truth is determined by an integer function. If we are able to show that the propositional form is true for some integer value, then we may argue from that basis that the propositional form must be true for all integers. There are three steps. Step 1, namely best case, show that a propositional form px is true for some basis case. Step 2, namely inductive hypothesis, assume that pk is true for some k. And step 3, namely inductive step, show that step 2 implies that pk plus 1 is true. Then, by the principle of induction, the propositional form px is true for all n integer or equal to the basis case. Okay, next, move to the example. Prove that n to the power of 3 plus 2n is multiple of 3 for any positive integer n. By using mathematical induction, next, the step 1 is, let's consider the best case when n equals 1. So we substitute the value 1 to n. We get 3. Yeah, we can see that 3 is divisible by 3, right? So the statement holds for n equals to 1. Step 2, assume that the statement holds for some positive integer k, which means that k to the power of 3 plus 2k is divisible by 3. Here we can see k to the power of 3 plus 2k equals to 3m, where m is an integer. And then, step 3, we need to prove that the statement also holds for k plus 1. Yeah, n to the power of 3 plus 2n equals to k plus 1 to the power of 3 plus 2 times k plus 1. Now, k plus 1 to the power of 3 we can write as k to the power of 3 plus 2k squared plus 3k plus 1. And 2 times k plus 1 we can write as 2k plus 2. Yeah, this is by distribution property. And then 1 plus 2 is 3. Okay, this we can written as k to the power of 3 plus 2k plus 3 times k squared plus k plus 1. This is we get by using distribution property. Okay, according to step 2, k to the power of 3 plus 2k is divisible by 3. Additionally, since k, we can see that 3 is outside the brackets, right? So since k squared plus k plus 1 is an integer, we can conclude that k to the power of 3 plus 2k plus 3 times k squared plus k plus 1 is divisible by 3. By mathematical induction, we have proven that n to the power of 3 plus 2n is a multiple of 3 for any positive integer n. Okay guys, I think that's all from me. I'm sorry if there are any mistakes, and thank you for your attention. See you. Assalamualaikum warahmatullahi wabarakatuh.